Okay, so the paint method is really fairly straightforward, except for the double buffering. So the first thing we do, instead of using the graphics object G to draw stuff, we're going to use off-screen. What is off-screen? Off-screen is the graphics object that we got from our buffered image. So what we're doing is we're, instead of drawing directly to the screen, we're drawing to that buffered image. Now when I set the color to 0, 0, 0, and then 0.05, this is a transparent black. Okay? And then I fill rect 0, 0 with height. This is just essentially fading everything that's on that buffered image just a little bit. It's sort of like clearing the screen. If I made this instead of 0f, if I made this 1, that would get rid of the trails completely. And if I make it 0.001, this is about the longest trail that I could possibly have. Well, aside from not clearing the screen at all, which is, no fade at all. But anyway, you clear the screen, essentially. And then this if all sprites is not equal to null. That's just a little bit of safety thing. And in this particular application, it's not necessary. But right here where I say all sprites dot acquire, by using that dot, I'm dereferencing the variable. If it was still holding null, if it had not been initialized yet, this line of code would crash. And so, because we don't always control exactly when this call to paint occurs, sometimes it'll get called when they click and drag the window around and stuff. We can't always be 100% sure that all of our variables have been initialized properly. And so this little if statement is a little safety thing to make sure that that the array list of sprites has been initialized before we try to call its methods. This is acquiring the lock. So we've got a multi-threaded application. Whenever you have a multi-threaded application, if you are accessing elements of an array list in multiple threads, it is important to have a lock where you lock it before you start diddling with the array list and you unlock it after you're done. If the two threads try to mess with this array list of sprites at the same time, that will also cause your program to crash. And so we acquire a lock, and then we go through all the sprites. For each sprite in the list of all sprites, tell them to draw. So a sprite is just a game object that can be drawn on the screen. Once you're done drawing everything, you release the lock. And all of this is drawing onto the off-screen image. Once you've drawn everything off-screen, you use the plain old regular graphics object and draw the buffer. X of 0, and then Y is the top space. This is where I shift everything down. I can treat 0, 0, I can treat my X and Y coordinates as the upper left-hand corner of everything, because in all the rest of my code, this is the only place that I have to use the variable top space outside of the constructor. Inside of all these other classes, I'm going to treat 0, 0 as being this upper left-hand corner of my drawing area, because I'm drawing on the buffered image, and the buffered image is shifted down so that its upper left-hand corner is right up here. And I shift it down by that top space variable. Null, because whenever you draw an image, the last parameter, well, we're going to just make that null. We don't really use the last parameter for anything useful in the draw image method. Run. Run is an infinite loop. It goes forever, or at least until they click the close window or the close button on the application. When they click the close button, it'll close up all the threads, and so run gets stopped. But it's going to just keep going while true until it's terminated. try and catch. So the idea with try and catch is that some things can throw exceptions. Like if you open a file and the file doesn't exist, it'll throw an exception. And if something might throw an exception, you have to surround that thing with try and catch. So when you tell a thread to sleep, it might get interrupted and woken up before its time. And if it does, it'll be an interrupt exception that gets thrown. And so you're going to try and sleep some amount of time and then catch the interrupt exception if it occurs. Now, this interrupt exception has a method print stack trace. You remember back in the day when I used to talk a lot about the stack and the heap? So the idea of printing a stack trace, when main starts, memory is set aside on the stack for main and all the variables that are declared within the main method. And sometimes main will call another method like set size. And when it calls that method, more memory is set aside on the stack for this new method and its variables. And if set size calls another method, memory is set aside on the stack for that method. If at some point an exception happens and your program prints a stack trace, it'll print out a bunch of information in the console about the stuff that's on the stack, and so you'll get to see a list of all the methods that are on the stack, what line of code within that method it was executing, and maybe something about the variables that that method has and the values that are stored in those variables. That stack trace is useful information for a programmer trying to figure out what was going on when the exception occurred, because usually an exception is a bad thing, and it usually means your program is going to crash. And so whenever I have a try catch, I will almost always in my catch just print out a stack trace and use that for debugging if my program ever crashes. And you could also say something like system.exit 1. System.exit just terminates or closes or crashes the program. It ends the program. If you don't exit, it'll print the stack trace and then it'll continue on and try to run the next instruction. And most of the time after printing the stack trace, it will then crash anyway. But if you know that, hey, something bad has happened, you may as well just go ahead and exit the program at that point. This just closes up everything. So if you have multiple threads running, multiple methods are open, this closes everything. Okay? A return statement will only close that top level method on the stack. But an exit will exit the entire program. The entire program closes. Okay, so we fall asleep for a short amount of time. We wake up. We acquire a lock. We go through all of the sprites one by one, get them out of the list, tell them to update. We call a doHit method on the sprite. Okay, so, and we pass it a puck. I have made this game, I've set it up so that every sprite has a doHit method where it receives a puck and then it does something intelligent depending on what kind of sprite it is. So when a puck hits the paddle, the puck is going to bounce off the paddle in a certain way. If the puck hits a brick, then the brick will disappear, or it'll die, and the puck will bounce in a different way. It bounces different than it would off of the paddle. And then if s dot is dead, so each sprite will declare itself as dead. So every sprite has an is. I've given every sprite an is dead method, and when it declares itself dead, the game loop will then remove the sprite from the array list or the lockable list of game objects. After we've gone through and handled all of the sprites, we release the lock and repaint everything on the screen. If we don't have the repaint, we won't be able to see the effects of the game loop. And so this causes the whole thing to repaint. One important thing to note. I've used a regular for loop here. And inside of Paint, I used a for each loop. Now both kinds of loops will go through all of the sprites in the array of all sprites. The difference, in a regular in a for each loop like this, I can call methods on my sprites, but what I cannot do is I cannot add items to or remove items from or move items around within the list of sprites. If I, in a for each loop like this, try to modify the all sprites array, if I try to add stuff, remove stuff, move stuff around within the array, it will cause what it calls a concurrent modification exception. And that's bad. In this loop, I am removing sprites from the list. Okay, all sprites.remove s. And because I'm removing items from the array list, I have to make sure that I use a regular for loop instead of a for each loop. If I had not been removing, then I could have done a regular or a for each loop by saying for each sprite s contained in all sprites. So these two lines of code that I just commented out up here are very similar to this one line of code, and normally if I can, I'm going to try to use the one line of code. It's less typing, it's easier to think about. This is just says for each sprite in the array list of all sprites. And I'm calling it an array list even though it's a lockable list, because a lockable list is just an extension of an array list. But if somewhere in that loop I'm adding or removing items to the list, I've got to do a regular for loop. I cannot shorten my code up into a for each loop if I'm adding or removing items. One other thing that's important to note. Say I'm in my loop and I've got this list, right? And I is at 3. Okay, so I've got my for loop. I'm going through. I went through. I was 0. I is 1. I is 2. I is 3. I've got this list of sprites, and I've given each sprite a name. This is going to be sprite A, B, C, D, E, F, G, H, I, J, K, L, M, N, O. So this is my lockable list. I'm going through each item, telling it to update and redraw, update and redraw, update and redraw. I'm on item D. Okay, it's at index 3. I is holding the value of 3. And I find out that D, after it updated, was a brick. The puck hit it, and it's got to be removed. So what happens? So D is removed from my list, right? But then everything else needs to get shifted left a little bit. Okay, so E goes into spot 3, F goes into spot 4, G, H, everything gets shifted left one spot. Now that one call to remove, that when I say all sprites dot remove s, if s is that D object, that one call to remove is going to remove it and then shift everything else left. Then the next instruction after remove, it comes out and it does an I++. So I becomes 4. Is no longer pointing at the 3 spot, it's now pointing at the 4 spot. And E was shifted left. And now F is in the 4 spot. E got skipped. Because D was removed, it was shifted left, and then I was shifted right. That item gets skipped in the next pass through the update loop. So you have to be a little bit careful. Now in this game, it doesn't really matter. It means that, you know, if that thing happens to be a brick, that brick is just not updated in the next pass. In a game, if you got a bunch of things and they all get updated and then all get repainted and then all get updated and repainted, most of the time nobody's going to notice if the update loop occasionally skips one item or another. But there are other applications of some sort of a loop where you're going through a list and removing items that satisfy a certain condition. Well, if you want to be sure not to skip things, you got to do something different. You might say I minus minus, okay? That'd be sure not to skip things, because if you're trying to remove everything that satisfies a certain condition and you might skip things and you don't decrement, well, then you're going to remove some of the things that satisfy the condition, but if there's something else adjacent to it that satisfies it, it doesn't get removed. So you have to be a little bit careful in these update loops. In this particular game, this little line of code, even though it's for completeness, it's good to have it. In this game, you're really not going to see any difference. But in some applications, that is an important thing there. So just be aware, if you're using a regular for loop, going through an array and removing items, you may want to decrement I whenever you remove an item. So after the update loop, we release the lock, we repaint, and I think that's it for the game. And we'll go through some of the other classes in the next video.